All right, so now we're going to talk about exponential and logarithmic equations. So you're actually solving for stuff now. This part is a little bit challenging. If you know your properties, though, it will make sense. Okay, so just bear with me. Skip over example 1. It's not really that important. But this property of equality for logarithmic equations, this is important. Let me get that. Oh my god. Y'all, I'm clearly too old for this. Here we go. There we go. Okay, so property equality for logarithmic equations. Here's what it says. So if you have log base b of x equals log base b of y, then you know that x equals y. So essentially what's happening here, if I write it out maybe a little bit differently, it might make more sense. I can cancel out the logs. I can just set the arguments equal to each other. As long as the logs are the same base, if you have log equals log, just cancel the logs out and solve from there. So that will come up in some of the equations that we look at today. Go ahead and look at example 2. So you have 3 to the x plus 1 equals 5 to the x. And it's pretty impossible to solve this equation unless you use logarithms. So remember, we're trying to get rid of the exponent because that's the tricky thing right now. So what we're going to do is, to get rid of them, use the inverse function, which is a logarithm. So I'm going to take the log of both sides. So I have log of 3 to the x plus 1 is equal to log of 5 to the x. So what does that allow me to do? Well, now I can use the power property that we learned in 5.6 to bring down the exponent as a coefficient. When you have one like this where it's x plus 1, put it in parentheses. It will help you because that needs to stay together. So that was the power property. Okay, so now what you're going to do is you're going to distribute. What the heck are we distributing? Well, over here on the left side, you have this log 3. I'm going to distribute that inside the parentheses. And I know it feels weird because we're going the opposite direction of what we normally do, but that's totally fine. So this becomes x log 3 plus 1 log 3, or you can just write log 3, equals x log 5. All right, now you have x's on the left and the right of your equation. You want them to be together. So what I'm going to do is I'm going to move all the x's over to the right side. Why am I moving them to the right side? Because it's the least amount of steps, okay? If you try to move them to the left, then you still got to move that log 3 that's in the middle there, so you're adding more steps. So I'm going to go ahead and subtract x log 3 from both sides. So I have log 3, oops, this should be x log 3. Log 3 equals, because this canceled out, x log 5 minus x log 3. All right, now I'm going to move this up here for the next step. Now what I'm going to do is factor out the x that's in common. There's an x in common in both of those terms on the right side. So I'm going to rewrite this as log 3 equals x times, because I'm factoring it out, log 5 minus log 3. The reason you're factoring it out is because you just want one x. That way you can get x by itself. The whole goal is to figure out what the heck x is. So you want to get it by itself. Now that I have x times log 5 minus log 3, I'm going to go ahead and divide both sides by log 5 minus log 3, which we're not used to dividing by something that's so long, like a subtraction problem, but you can do that. I'm going to do that on both sides. It may help you to see it better to put it in parentheses. It's up to you, though. So then all those logs on the right side cancel out. So now I'm left with log 3 over log 5 minus log 3 equals x. Now you're going to type this into your calculator. And you need to type it in exactly as it's written. Don't do like log 3 equals, log 5 equals, log 3 equals, and then divide and subtract everything. Don't do that. Type it in exactly like it is. You can either use your fraction key, or if you're going to do division, make sure you put parentheses around the top and the bottom. Try that. If you're struggling with it, you can ask a friend, you can ask me, whatever, I'll try to help you. But plug it in. It should be about x is equal to 2.15-ish. But round to the nearest 3 or 4 decimal places. I don't want to use too many decimal places because I don't want to confuse you if your calculator rounded it a little bit off. But it should be right about there. Again, just pay attention to what it says to round to on online homework. All right, so that's example 2. You figured out what x is. Now, example 3 says, what's the solution to... Oh, I forgot. Cross this out. That's a mistake. This section got a little screwed up. So you have ln of x squared minus 16 equals ln of 6x. Now, this is where you can do that property, equality of logarithmic equation. So if I scroll up here, remember this property said that we can, if there's a log equal to a log, if you look over here, I can cross out the logs and just set the arguments equal to each other, which is exactly what we have on example 3. You have ln is equal to ln. So I'm just going to drop out the ln and set my arguments equal to one another. You know what people tend to do? They tend to distribute, which you cannot do. No, big no. Don't do that. No. Okay? Don't do that. All you gotta do, make it easy on yourself. All you gotta do is drop the logs, set the arguments equal to each other. Okay, so now you have a quadratic. Yay! Quadratics are back. So what I'm going to do is, I'm going to get this equal to 0. Remember, whenever you have a quadratic, you want to get it into this form. This is standard form of a quadratic. You want it to look like this. So I'm going to go ahead and subtract 6x from both sides so that this equals 0. So I have x squared minus 6x minus 16 equals 0. Now you can factor. So if I set up my factoring x, in the top I have negative 16, in the bottom I have negative 6. So what multiplies to be negative 16 and adds to be negative 6? That would be negative 8 and 2. So my factored form becomes x minus 8 times x plus 2 equals 0. Now you set each factor equal to 0 and solve. So I get x equals 8 and x equals negative 2. You do need to check for extraneous solutions. So the rule is the argument of your log cannot be 0 or something negative, okay? So what that means is when you have like ln and then there's some number in this number has to be greater than 0 or positive if you want to think of it that way. So you can think to yourself when you plug this stuff in, the easiest way to know which one's extraneous, it's probably going to be the negative one, not always, but usually. So if I plug in negative 2 into 6x over here, 6 times negative 2 is negative 12. So that's no-go. So I can already tell this is extraneous and this is 8. But just plug each answer into the argument. If you get a negative number or 0, it's extraneous. Typically, it's the negative one, not always, though, so watch out for that. All right, go ahead and flip to the next page. Now, once again, there's this extra ln in there, so just ignore that. Now you have 2 ln, that 2 is still there, okay? So 2 ln of 3x minus 2 equals ln of 5x plus 6. Now you do not have log equal log, because this 2 is out in front of there. That's what's tripping this up. But you do have a property that can help you bring that coefficient in to the log so that you do end up with log equals log. So I'm going to use the power property to bring that 2 in as an exponent. So I have ln of 3x minus 2 squared equals ln of 5x plus 6. So that is the power property. When in doubt, see if you can use the power property. It usually helps out quite a bit. Now you have log equals log. So I'm just going to drop the logs out, and I have 3x minus 2 squared equals 5x plus 6. 3x minus 2 squared is not 9x squared minus 4. Remember, you can't just distribute that exponent. What that means is that this is 3x minus 2 times 3x minus 2 equals 5x plus 6. So now what I'm going to do on this left side is FOIL. And if you do not FOIL, you will not get the correct answer. So first times my first. 3x times 3x gives me 9x squared. 3x times, let me write out FOIL so you can actually see what I'm doing. Then I do my outside times my outside. 3x times negative 2 gives me negative 6x. Negative 2 times 3x gives me negative 6x. Negative 2 times negative 2 gives me positive 4. That's equal to 5x plus 6. So now I'm going to combine my like terms. I have 9x squared minus 12x plus 4 equals 5x plus 6. And again, just like on that last example, you have a quadratic now, so you need it to equal 0. So I'm going to go ahead and subtract 5x from both sides, and the 6 as well. That way, everything cancels out on that right side, and it's going to equal 0. So I have 9x squared minus 17x minus 2 equals 0. Okay, now you can factor. So, set up my factoring x. Be careful. Be very careful. Now you have this coefficient in front of x squared. So I need to multiply my first term times my last term to get that top number in the x. So 9 times negative 2 gives you negative 18. And then my middle number is negative 17. So what multiplies to be negative 18 adds to be negative 17? Well, that would be negative 18 and 1. Remember, you can't do that shortcut now. You have to split up this middle term, negative 17x, into negative 18x and 1x. So I have 9x squared minus 18x plus 1x minus 2 equals 0. And now I can factor by grouping. So in that first parenthesis, I can pull out a 9x, and I'm left with x minus 2. I can't pull anything out of the second parenthesis, so I'm just going to leave that as plus 1, and x minus 2 equals 0. I'm going to continue this up here. Now, I'm going to write what's on the outside of my parentheses first. So 9x plus 1 times the one that's in common, which is x minus 2. And set that equal to 0. Now I can set both parentheses equal to 0 to solve. So, subtract 1, I end up with 9x equals negative 1, divide by 9, and I get x equals negative 1/9. There's one answer. Then I'm going to add 2 to both sides, and I get x equals 2. Again, check for extraneous solutions. So you're plugging both of these answers in to the original problem to see if any of them give you a negative answer. Go ahead and try to do that. You can just do it on your calculator. But what should happen is that negative 1/9 ends up being extraneous because you get a negative number, and x equals 2 is your answer. Again, just plug it back in to the arguments. Plug back into arguments. And by arguments, whatever the big numbers are in the log. All right, there's that one. Letter C, this one did not transcribe very well, so let me rewrite the problem. Ignore this. This is an insanely easy problem that you guys learned in Math 1, so don't do that. What we're going to do instead is log base 2 of x plus log base 2 of x minus 3 equals 2. So now you have a log plus a log equal to a number. So you don't have log equals log like we did on the past two problems. Again, ask yourself, is there a property you could use to try to get just one log? We like when we just have one log rather than having multiple logs. So I'm going to use the product property to combine these. Product property says if you have two logs added together, you can condense them by multiplying together the arguments. So I'm going to rewrite this as log base 2 of x times x minus 3 and set that equal to 2. So again, that is the product property. use that foldable if you're confused. That way you have the properties in front of you at all times. So, now what the heck can I do? Well, I can rewrite this as an exponential to try to solve the log. So I'm going to do the little ghost. I have 2 to the second, and then I circle back to my argument. And yes, this argument is all one thing, x minus 3. So I have 2 squared equals x times x minus 3. So I'm going to simplify this just a little bit. And again, this was just the definition of log / ghost, however you want to think of it. Simplified a little bit. So I have 2 squared equals 4. Here I'm going to distribute that x through. So I have x squared minus 3x. And now you have a quadratic. So you got to get it equal to 0. I'm going to go ahead and subtract 4 from both sides to do that. So I get 0 equals x squared minus 3x minus 4. And now you can factor to solve. Set up my factoring x. In the top I have negative 4. Bottom I have negative 3. What multiplies to be negative 4 adds to be negative 3. That would be negative 4 and 1. So I get x minus 4 times x plus 1. Solve both of those, set them equal to 0, and you get x equals 4 and x equals negative 1. Again, check for extraneous solutions. Plug them back into the arguments here. This one's easy because if you plug it back into the x here, you can see where my arrow is, plug it back into the x, you don't even have to do any math because that x can't be negative. So you automatically know that x equals negative 1 is extraneous, but 4 does work on that one. So that would be your answer. All right, that's it for today. This is probably the most challenging section. So take your time on your homework. Think about those properties. Use your foldable. Have your notes from 5.6. Do these properties. Very important. If you do not have that foldable, definitely use that. This is